And welcome to the Smash News Network, Least Busted. Naming news. Whew. Congratulations on realizing the channel exists. We've got more spectacular imagery of the closest star for all of you stargazers. We've got two named sunspot groups. They're both in the southern hemisphere. More on that coming. First, a colorized magnetogram. And there you have the magnetic fields. And we'll zoom out to show the full disk. There's the full disk magnetogram from the Solar Dynamics Observatory. Here's just the southern hemisphere. This is 1700 angstroms. That's part of the UV spectrum. And both of those sunspots, alpha class, not real large, not likely to produce major flares. Here's 94 angstroms. This is ionized iron from the Solar Dynamics Observatory. Looks like another active region may be rising there, right over here in the northeast. Radial flux is quite low. I think it might have dropped below 80, actually. Indeed, it did. There's the 1-year chart. The black line there is the 10.7 centimeter radial flux. For you new viewers not familiar with solar activity, that is the most proportional number to sunspot number. So as you can see, this red line down here, that's sunspot number. Black line is radial flux. You can see how directly proportional those values are. And here's the space weather enthusiast dashboard. Still expecting some geomagnetic unrest from a coronal hole late tomorrow. Radial flux down to 78 there. So low levels of solar activity despite a couple decent-sized sunspots. I think there's a bunch of plasma in between Sun and Earth once again. And let's take a look at global seismicity. So there's the past 90 days, and we've had a bit of an uptick here once again. There is a 7 magnitude earthquake drought going on. Keep in mind, any of these quakes could be foreshocks if you're in an earthquake-prone zone. Earthquake droughts tend to end in large earthquakes, and we're seeing quite a bit of activity kicking up here around some plate boundaries. Largest quake of the past 24 was a 6.3 in southern Iran. Smash Team found out about this before the video premiered yesterday at smashomash.com/smashteam. And that 6 magnitude was a foreshock indeed. Again, keep in mind, folks, any quake could be a foreshock. Taiwan also saw a 5.0. At least one quake in the South Sandwich Islands region. I can see it there near the Antarctic plate boundary. Tonga seeing a deep quake there at a 4.6 magnitude, 230 kilometers. South Indian Ocean seeing a couple of quakes there, including that 5.3. And this 6.0. So once again, a 5.3 was a foreshock to a 6.0. We didn't see any tsunami alerts lighting up. I don't expect any associated with the current quake profile. 5.6 also struck the East Pacific Rise. That would be the most recent. Next, we're looking at the astronomy picture of the day. Why? Well, because it's volcanic. Yeah, the astronomy picture of the day. It's a light pillar created by the sun at a large angle, shining down through some volcanic ash cloud. Great view here of, I believe it's Mount Etna. Don't worry, we'll zoom out. I want to show you the close-up first. Great high-resolution volcanic image here at apod.nasa.gov. And some lens flare. You can see there those little beams caused by diffraction through the lens. A feature known as lens flare. You've got some solar lens flare showing up through the atmosphere, and you've got some lens flare on the camera as well. They're showing up at the same time. apod.nasa.gov if you want to check it out yourself. Let's see what volcanoes are currently erupting. The Isle of La Palma basically a giant volcano, is producing an 8,000-foot plume of volcanic ash as it explodes. Tsukunosejima, 9,000-foot ash plume there, flight level 090. Semeru also explosive eruptions happening there on East Java. "80 quakes on the 10th occurred at that volcano. Semisopochnoi, no activity observed in the Aleutian Islands from Semisopochnoi. Fuego in Guatemala exploding, flight level 150. It's a 15,000-foot ash plume. Sangay exploding, 19,000-foot ash plume from Sangay. Revenador exploding, 15,000-foot ash plume from Revenador. Sabancaya, intermittent puff emissions. No flight level listed, no size of the volcanic ash plume. Have you seen our merch? One of the merch items there will remind you and your friends and foes to not pole vault the caldera. And we try to be a little bit edgy with the merch, sort of in the tradition of Spencer Gifts. I would say to all of our viewers, Universum Liberate. If you don't know what it means, you've got the internet, you can probably look it up. One of the things you should look up is our own homepage, where we welcome you to the Neo-Renaissance. Congratulations on realizing that the channel exists, that smashomash.com exists. Please click the links below the video and support the channel by becoming a member of the Smash team. We needed to replace something a little bit more feature-rich. We needed to replace something called Patreon, and so we did with the Smash team. Also very interested in replacing Facebook. So make sure you sign up. Also, we've got a forum there. That's completely free. You can view that stuff without even logging in. Let's look at some magnetic data. Here's the GOES magnetometers over the past 3 days. Fairly normal nominal range here, nothing to write home about. A bit of a low reading there on the GOES 17 recently. Here's the heliospheric current sheet's polarity. Yeah, the sun puts out a bunch of plasma, and it gets oriented in a polar fashion to either the north or south pole. The plasma in the Earth zone is currently south pole oriented, shown in red. That's the south pole current sheet, the one in which you're likely currently in. Please leave a comment if you're viewing the video from a different planet, galaxy, plane of existence, dimension, timeline, spaceship, etc. Universe, multiverse. Here's a line of sight ecliptic plane field plot. It shows you the solar magnetogram as well. No big action happening, magnetically speaking, at the moment, besides some coronal holes, and here those are. The blue lines here are the sun's B field. B field being the field that goes through the magnet. South pole-oriented coronal holes there, rotating through the Earth-facing zone here. That's what we can expect, that geomagnetic unrest coming late tomorrow, according to NOAA. And here's a visual of it. This is actually two wavelengths, 211 and 193 angstroms. You can see those well-defined coronal holes there, although not reaching up to the equator. So those are non-trans-equatorial coronal holes. If you want to read about historic coronal holes, head to solon.info. Solon.info/solar. All kinds of information there. Likelihood of major flares, not very high. 2894 and 2896 are both alpha-class sunspots. Alpha-class sunspots only feature one magnetic field polarity, which makes them unlikely to produce major flares. And we just did see a little B-class intensification there while we did the recording for the show. Next, the proton flux. No relativistic particles striking recently. None expected. No coronal mass ejection warnings in place. No solar flare warnings in place. We did see a weak coronal hole wind stream arrive here as the density dropped down. Well, not really. Just a small intensification there of the solar wind speed. We may see the density drop off here and the pressure, and the speed rise up. That could be still at about 12 protons per cubic centimeter at the moment for the solar wind density. Solar wind speed just over 300 kilometers per second. I would expect to see the density drop down here and the speed to rise, as this looks like the leading edge of a coronal hole wind stream. I think part of it's already arriving here. We may also see another increase in the density, I would say, in the next day and a half. KP index currently at 1. That is a measurement of global geomagnetism if you're new to the channel. Once again, congratulations on realizing we exist. I don't know how you found us. Let us know in the comments. We're all too interested in how you find our channel. Next, magnetohydrodynamic pressure here over the past 4 hours. The scale you're looking at in this model is nanopascals, magnetohydrodynamic pressure. It's 4 hours of the Earth geospace here out to about 12 Earth radii. Nothing too exciting happening here, pretty homogeneous pressure around Earth's geomagnetic moment. Next, ground magnetic perturbations, geospace delta B, changes to Earth's B field. This is actually magnetic flux density nanotesla is the scale here, showing you changes to Earth's own B field here at the ground level. Pretty calm conditions as far as geomagnetism in the past 4 hours. Next, we're going to do a solar system forecast. Here's where stuff is now. There's where things should be in a week. Leave us a comment if you're frightened of Uranus being in line with Venus and Mercury and Mars. Leave us a comment if you're frightened. Leave us a comment if your head's in Uranus. Leave us a comment if you're orbiting Uranus. Next, a star chart. I like to use in-the-sky.org and ask our viewers, where will you be when Cygnus rises? Let's take a look at the likelihood of coronal mass ejections. There's one sort of happening on the far side of the sun. Let's take a look at the view from stereo A here at Lagrange 5. That's the left pane. You can also see Mercury in this image. And you can see a little bit of activity looking like it's propagating here on the far side of the sun. Earth would be off to your right from the perspective of stereo A. And from the perspective of the right image, that's Lagrange point 1, the LASCO-SOHO C3. No coronal mass ejections in the available imagery. Next, our cosmology segment. We'll make this one a little bit brief, although there are some interesting articles to cover, like massive radio sources known as black holes, by some, have tantrums, and scientists have finally captured gamma rays from such fast outflows. Now, I don't know why this is news. I'm going to let the article scroll anyway. I don't know why catching gamma rays from a massive radio source believed to be a, quote, black hole, end quote, would be news, but we've got tons of different gamma ray sources. That one's from SciTech Daily. Here's another one. Now, this one's very important, I think, in terms of geomagnetism. Recreating deep Earth conditions to see how iron copes with extreme stress and pressure. Now, I'm not sure how high of a pressure they're going to get here, as there is a little bit of dissent in terms of how Earth's geomagnetic field is generated. So here's some data that our viewers may be interested in. The metal at the inner core is under pressure about 360 million times higher than we experience in our everyday lives. 360 million times the pressure that you would see here at sea, well, when you're at sea level. Of course, I'm at about 400 feet of altitude. But in any case, guess what happens? It becomes super ionized, probably, when you get it under millions of pounds of pressure. The same way hydrogen becomes a flat black colored metal at high pressures. Also, water becomes, the oxygen nucleons in water become locked into a cubical lattice structure. So we're talking things like diamond anvils here. And so this is an important article. Once again, superionized materials under great pressure are the future of materials science. So maybe have a read of that article at SciTech Daily. Our random object today is number 201 at the Neil Gehrels Swift-Bat X-ray Observatory. If you scroll down to number 201 in the transients list, you'll find the X-ray source, which is a low-mass X-ray binary, by the way. known as Maxi J0556-332. Here are the hard X-rays from that low-mass X-ray binary. Here's some visualization of it, and it looks very dark there because, well, it has to do with its orientation, I would guess. So that's the SIMBAD portal, and we'll just close down the SIMBAD portal and take a look at the CDS portal, which has got all kinds of data. By the way, this is only going to be bright in certain portions of the spectrum. As you can see, there are some dark spots in the photometric points. This is why it looks so bright in X-ray. That's the view from the Chandra X-ray survey, and you can see it is quite a bright X-ray source. And the crosshair is off a little bit there, indicating that perhaps there is an orbiting companion, indeed probably part of the reason why it's classified as a low-mass X-ray binary. If you want to read more about it, it's again Maxi J0556-332. You can find it at the CDS portal and at SIMBAD, as well as at the Neil Gehrels Swift-Bat X-ray Observatory. Those are the hard X-ray monitors of over 1,050 objects in space. One more article for you here, too. What's Killing Galaxies? Solving a long-standing mystery in astrophysics. By the way, we've never seen a galaxy die. What they're talking about is a reduction in star formation or something like this. When they refer to killing galaxies, the Virgo cluster here traced, oh great, so it's a carbon monoxide survey. So that's very interesting, as there is an area with a lot of carbon monoxide. And you can see these galaxies have very varying amounts of carbon monoxide. And as it gets closer to this carbon monoxide source that's very bright, you can see there's more carbon monoxide in each galaxy. Yeah, there's a lot of carbon monoxide in space, folks. So we know that the sun seems to produce some carbon on its surface. That's why we use the 1600 angstroms view from the SDO. A little bit of hazardous materials floating around in space there in the form of carbon monoxide. Don't breathe it. Don't worry, folks, it's very diffuse. That's today's cosmology segment. It was integrated to the daily space weather video. We've got over 200 videos alone just in the cosmology segment. Check out all of our playlists at youtube.com/smashomash/playlist, the official channel of the Smash News Network, least busted. Name it news. Let's get back to it. Charging hazards, non-existent. And the electron flux levels have dipped, as we typically see with a coronal hole wind stream. There's the 1-year chart of the electron flux, and there's a 3-day chart. You can see that recent dip. Looks a lot like the arrival of a coronal hole high-speed stream. Here's the forecast model, and I would tend to agree. I would tend to actually place tomorrow a little bit lower. Probably going to be more like down here somewhere. A little bit of an electron forecast adjustment for you there. That's NOAA's forecast, the green boxes. Next, we're going to show you the total electron content forecast, which is the electron density in between about this space from your GPS satellite through the inner Van Allen belt down to your ground-based handset. And we're seeing continued anomalies over the North Atlantic and North America, as well as the Central Indian Ocean area. A little higher than usual levels of electron flux. Next, the ionosphere layer. Here's the F layer. This is 300 kilometers of altitude. Your animated ionogram from the Australian Government Bureau of Meteorology. Yes. And we're seeing anomalies once again here, both in the high and low frequency variety. Rather than try to explain it, I'll let it play through and I'll show you the anomaly map instead. Here's the anomaly map. This is showing you anomaly in megahertz. This one shows you megahertz, the vibrational frequency of those layers, of that layer. And this is the anomaly, which is the anomaly in megahertz from the 30-day median. So we're seeing high-frequency anomalies here around Antarctica and so on, and low-frequency ones all around the northern hemisphere and the South Atlantic anomaly, which is located about here, the weakest spot in Earth's magnetosphere. Anyway, there's a latest image that's 10:30 Universal Time. Ionogram, and Anomalygram. All right, here comes bonus features. We're looking at hydrogen alpha imagery here from Larmouth, Australia, and look at the sun is blowing up. It's going to kill us. I take back everything I've said. The sun is exploding. It's going to kill us. Everybody get in your underground bunkers right now. Look at what's happening in Larmouth. They're observing this event as it happens. NASA hasn't been able to scrub this from the record yet. Just kidding, folks. That's caused by clouds. In the meteorology segment that we premiered before this video, we were talking about the way water emits radiation, and there you can see it happening. It's because this telescope's looking at hydrogen alpha imagery. So let's take a look at some better imagery here. Cerro Tolo, once again, Cerro Tololo in Chile. And you can see there are some filaments here, and we may upgrade our lack of a coronal mass ejection watch to something at some point today. We'll be keeping an eye on it, and when I say ion, well, pardon the pun. Next, your solar intensitygram and colorized magnetogram. Do we see anything rising up there? Not yet. These sunspots are still alpha class. They've been stable over the past 24 hours. Here are the fields. Likelihood of major flares not so high. And that may be a sunspot rising. We'll have to keep an eye on that as well. Here's the GOES 16 SUVI imagery. Pretty current images here. And you can see quite a bit of filaments there around the eastern limb. Again, we are expecting to watch a far side coronal mass ejection happen throughout the day today, perhaps. It looks like it's kicking off. Anyway, we'll close things out with two of my favorite wavelengths, 171 angstroms. That's this one, ionized iron. It's iron 9, I think. And here is ionized helium, 304 angstroms, also from the Solar Dynamics Observatory. Thanks again for tuning in, viewers. Congratulations on realizing the channel exists, and may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted. Name and news.